All right, well, thanks so much. Welcome to today's webinar, Fundamentals of Data Analytics, sponsored by Oregon State's Professional and Continuing Ed Unit. I am Melanie Mitchell, the Director of Professional and Continuing Ed. And this session is going to be recorded, and we also want to hear from you, so use your chat box. The entire panel here today can help answer your questions. We'll save more questions for the end, and then tomorrow we'll send out a recording to this presentation along with the presentation slides. So feel free to share, feel free to respond back with any further questions that you'll have. PACE at Oregon State, we engage with community through educational opportunities that are both for personal enrichment and professional development. We offer hundreds of courses and certificate programs to the public. We have tangible value and create quality programs that address educational, professional, economic, and development goals for our organization and others. So we also do corporate training for a critical mass of 8 or more. If there's interest, we can also bring these courses in company. So we feel that partnerships provide amazing opportunities for professional and continuing education, and as our audience advances their careers and fosters personal development, and our courses offer a benefit to communities of all shapes and sizes. And so PACE, we are committed to bringing the best of Oregon State to the people of all ages and industries, and we're proud to be partnering with Kevin Hannigan to do just that. So our webinar to introduce Kevin Hannigan to you. Our agenda, we're going to go over, I'm going to introduce you to Kevin. We're going to go over the fundamentals of data analytics, the course offering, who would benefit from this program, and some additional information about the program, and save some time for Q&A and PACE contacts. So Kevin here, he is the author of 4 books, Building State-of-the-Art Web Pages, Custom CGI Scripting with Perl, The Practical Guide to Curl, and Programming Solutions with the site with Decision Site Analytics platform. So Kevin also teaches in our Web Design and Development Certificate program offered here at Oregon State, and we're very proud to be working with him as long as we have. Thanks, Kevin. He's also worked for a variety of software companies, universities, and corporate training centers as a course developer, trainer, and consultant. And he's currently the Vice President of Knowledge and Learning at Clerk. So thanks, Kevin, so much for being here.
Absolutely, pleasure to be here.
Can you start to tell us a little bit about the fundamentals of data analytics?
Yeah, so again, thanks for everyone attending. What I thought I'd do in the next couple of minutes or so is kind of take you through a story of where we've come to where we're going, and why it's important for people nowadays to have a fundamental of data analytics, or sometimes you might hear it called data literacy. And to kind of start that story, you have to understand, what's going on in the industry over the last decade or two. And so the slide you see here, the Economist cover of the magazine has this slide called the Data Deluge. And what that means is, with the advent of social media, the digital revolution with technologies and innovation, the amount of data that's out there is astronomical. And companies can use it to make a competitive advantage. And I'll show a couple examples later on. And it might not just be what you're typically used to seeing, like feedback forms. It might be different types of data, that what we call unstructured data, and that ties to some of those big buzzwords you might have heard, which we'll talk about in a second, like big data. So to kind of level set, the amount of data that's out there is just massive. I mean, just to kind of put it in context, now there's about 500 million tweets each day. Some of those tweets are feedback on businesses or services. So if that business or service can harness that data and perform things like sentiment on it, or get out keywords that are applicable to customer service or success, that's going to give them a competitive advantage. YouTube, there's over 400 hours of new videos in YouTube every minute. And there's a lot of good information. In fact, being in the training business that I'm in, I'd argue that, sometimes the biggest competitor is YouTube, because it's free, it's massively available, and it has a lot of content for everyone. It might not have the governance that you would want with a structured learning environment, but the amount of content that's out there is incredible. Then you have things like Facebook and just email and Instagram and Snapchat. There's billions of pieces of content that are made available to people every day. So the foundation of data analytics is first understanding that there's these massive amounts of data available, and how do we make use of it, and into how we best make use of it. If we can go to the next slide, you might have heard this buzzword, big data. And to understand how to best use it, you have to understand how your data is organized, how your data is changing, how it's shaped, what are the different attributes. And there's a lot of different definitions of big data out there. The way that I like to refer to it, and it's commonly referred to, is sometimes called the 4 V's: volume, velocity, variety, and veracity. Is that data is not what it used to be before. Before, you used to have what's called data at rest. It's just a relational database, an Excel sheet that had lots of data. It might be customer demographics, it might be sales reports, it might be invoices. Now you have that, but the volume, as I just showed you, is exponential. It's much bigger. We're talking about terabytes to exabytes of data that a company has at their advantage. It's not like they can just look in a spreadsheet at that and come up with business conclusions. Well, you also now have not only data at rest, but you have data in motion, and that's the velocity factor. It's data that's actually streaming. So you might have milliseconds or seconds to respond. You know, example could be you work for a supermarket chain and someone's going through an order and they realize that you scanned a 6-pack of Coke or Pepsi, and they want to do an upsell to maybe a bag of chips or similar. That data is in motion. It hasn't actually sat, and you're looking at historically, you're making a real-time decision on that. Track and trace systems, UPS, post offices, airplanes use data in motion quite a bit to make real-time decisions on the analysis, as opposed to looking at things historically. But now you also don't just have the velocity, you also have the variety of data. So as I mentioned on the previous slide, there's many more forms of data, and a lot of it isn't what is typically called structured data. You would now call it unstructured. It might be an email, it might be an image, it might be a video. And imagine you work for an airline company and someone has posted on one of their social message media streams content about that airline agency, or maybe if it's a direct email to customer support. In that email, tons of information the company can use analytically to make decisions, but you have to understand how to interpret that data. So for example, I would assume that email would have the customer's frequent flyer number. It would have the flight number. They could pull in the seat that that person sat in. They could pull in the route that that person took, like Boston to LA or LA to New York City. They could pull in any sentiment, like was it good, was it bad? They could pull in how much they paid. And as you start aggregating that data, you can start getting trends out of that around, you know, maybe there's possible issues with certain flights. Maybe there's certain issues with seats being too close to the window and being cold. Things that you never could have done before, but now you have access to the data and you have analytic tools that allow you to aggregate it. You're able to make those better decisions to impact your business. And last but not least, there's a lot of times where the data might not be, I don't want to say it's not consistent, but it might be incomplete. And we call that data in doubt. And what do you do if there's a data set or there's parts of your data that's either ambiguous or maybe even deceptive? You don't want to get a false negative or a false positive. You want to understand tools that allow you to infer information from the massive amounts of data without taking cues from inconsistent or potentially deceptive data and making incorrect decisions about those. Because the whole issue with big data, the whole concept is you're using this to your advantage as a business to make better decisions and to get up on your competition. And so being able to understand the analytics of this is going to make you more successful in a business. And just to show you a couple examples of where this might play into business, if we go to the next slide, I pulled out 3 that I think are pretty popular and powerful examples of what might be done. So the first example is Netflix. They're streaming videos, and they do 2 things that are really making good use of data that they're receiving. Netflix is one of those true companies that's a champion of analytics today, and specifically using predictive methodologies. one of the things that they do is they do specific audience targeting. Each individual user might get an experience that's specific to them or different every time they log in. You get those recommendations. It has some artificial intelligence built in. If you like these videos and movies, you'll like those. And that type of consumer experience is all driven by data. It's buying patterns. People that like video A also like video B. Being able to go through that volume of data allows them in real time to get the data in motion aspect to help people. They don't just do very hardcore statistics. You know, doing some predictive modeling, as we'll see in a couple of slides, is requires, you know, some heavy number crunching, but they also do some pretty basic stuff. So they're really good at something called A/B testing, which we talk about in the full course for this. Is you give two different user populations a similar environment, like the Netflix webpage, but you change one thing on it. So maybe you move the login button to the top instead of the bottom, and this allows them to look at the feedback and the scores and the results of how each group uses those environments and make decisions on whether that's going to help them in the business. And they do that quite successfully. And it's, I wouldn't say it's basic statistics, but it's not that advanced concept. So Netflix is a good example where they use a wide range of analytic techniques to better their business and their market share. Another one is UPS, the shipping company and delivery company. They actually place sensors on all of their vehicles. And these sensors send a lot of data and metrics back to a central repository across their entire fleet. And what they do with that data is it helps them optimize things like dispatch planning or driver routine, or sometimes they'll optimize maintenance costs and fuel. So they know if certain, you know, cars tend to break down at a certain point, they'll be proactive and start doing repairs before that point hits, knowing that over time that data will consistently change. They're always looking to do that to improve their trucks and their deliveries. It might also help them organize their routes. They might realize that they have driving patterns where one driver is going out of his or her way to make the route, where there's possibly a shorter, faster way for another driver to make it. So route optimization, as well as maintenance of the trucks in general, is a huge way that UPS stays profitable and in business. And it all relates to data in motion and data in rest, and being able to analyze and interpret that data. You could even look at a sports organization like the US Tennis Association and the US Open. They use a lot of analysis that'll help actually us as fans look at their favorite players, but it also helps the players improve. So they might take data and look to see if there's things that are correlations between a player. So for example, the speed at which they serve versus whether they get an ace on that serve or not. And that data is fed back into the players so they can make analytical decisions. And we'll talk in the full course about this concept of correlation versus causation. And they're able to pull out, okay, if I do this, there's a good chance that Y will happen as a result. If I backhand against this opponent, I have a better chance. And this whole concept of, you might have seen the movie Moneyball, of using analytics to actually better the sports performance is another aspect of using data in business, whether it's to get a performance advantage or to get a higher market share or increase your revenue, limit expenses. The examples kind of go on and on. So if we can go to the next slide, we've kind of set that there's tons of data out there. There's tons of techniques you can use to analyze it. One of the other things that's happened with the technical and digital revolution is there are now tools that are available to an average user to interpret that data. And that's what we call the democratization of data. So Google defines it as the process of expanding business information and the tools to analyze it to a much broader audience. So kind of to level set where we are in the story, there's a lot of data out there. We understand the benefits of how data can help you in your job and help your business. And there are tools that are on the marketplace that don't require you to be a PhD in statistics to access that data. and use it for your advantage. That's a good thing. But as you see on the next slide, what that's presented to the world is what's called the analytics gap. And there's a couple examples. If you go Google the analytics gap, you can pull up the article that I show there. But what that basically says is data is growing massively. The ability from these consumer tools to access the data is growing rapidly. But what's not growing is the data literacy of people who know how to interpret it. So as a consumer, maybe you use Excel, maybe you look at spreadsheets, maybe you look at basic visualizations, but now you have access to all of this data. And we're telling you, you don't have to be a data scientist, you don't have to have a PhD in statistics, but if you have the tool that's going to create, for example, a scatter plot that shows you if two factors are correlated, you need to understand what a correlation is in order to be able to make a business decision on that. If you're looking at a distribution of sales across your different segments, and that's shown in like a bar chart as an example, you need to be able to understand that bar chart and interpret it. You need to understand, is that bar chart normally distributed? A very common example that I see often in the business world is a lot of people understand what an average is. So you might say the average sales is $5,000 a day. But what they don't realize is there's a lot of stuff behind whether you use average. There are other tools that show similar. So there's mean, there's median, there's mode. And depending on how your data is structured, you might have had one day like Black Friday, for example, shopping right after the day after Thanksgiving, which is a complete outlier, and it's maybe 100 times more than any other day. Do you really want to include that in your data set to get a true average of what your average sales are on a non-holiday like that? So examples like that, you can always make statistics say what you want it to, but you really have to understand how to interpret the data, what analytic techniques to use, because you now have, with the democratization of data, access to it, and you have tools, many of them free, that allow you to analyze it. You need now the skills to interpret them. And so the gap is truly, you have access, but you don't know how to interpret the data. And when we say closing the analytics gap, it means how do we educate average business users to understand and interpret what the data is trying to tell them. And that basically is the course, the fundamentals of data analytics. So on the next slide, we can kind of show you when you get into what you would try to learn from a course like data analytics, the first part is always about the data. Because as I said before, you make some assumptions based on how the data is set up. So we have to learn a little bit about data fundamentals. Is the data categorical? Is it continuous? What's the type of data? Is it ordinal? Is it real? And these might sound like complex topics on the webinar if you haven't been exposed to them. But for example, a continuous data set would be something like a demographics of a customer. It might be their age. There's a continuous cycle from, let's assume you start at adult, so 18, where your oldest customer might be 99. It's a continuous variable, and there's certain techniques you would want to apply to those, but you also have categorical variables, and those are things that are not following a continuous path, like gender. There's male or female, that's it. Or regions, and you might be in a sales organization that has 3 regions in the US, East, Central, West. So it's a discrete, finite list of 3 buckets, and you would do different techniques on that. So you learn about the fundamentals of data, you learn about the types of data, you learn about the aggregations. So that example I showed before, when would you use a mean versus a median versus a mode? And all of them explain examples using common business examples, so you can kind of see why it's a very important reason to do that. We then talk about data distribution. So how is your data distributed? And that's important because, again, as we get into understanding analytic questions that you want to ask of your data to answer business problems, you have to understand how your data is distributed. So the first part of the course goes into, all right, I need a level setting of how is my data organized and structured. From there, we go into some, what I would call basic analytic techniques that you would now apply, and we show you some of the tools that you can use for free on how to do that. So some of the stuff we'll use Excel, some of the stuff we'll use some free online tools to kind of give you a wide variety as opposed to just picking one of how you would answer common business problems. So the first one we'll look at is sampling and bias. If you're trying to look at a customer demographic, which could go across any industry, sales or marketing or whatever, you're always trying to understand customer demographics. It's not practical to look at, let's say you have 1 million customers. You can't look at 1 million customers. You have to sample it and ideally do some type of random sampling, but you have to understand the concepts of analytics around sampling and bias to make sure you pick the right customers. So it is either truly random or based off what you want. Otherwise, you could pick and choose customers that help you tell your story, which might make you get the answer you want, but it's not truly statistically accurate. So we kind of go over that. We go over the central limit theorem. We talk a lot about statistical inference. We talk about correlation versus causation. So why two variables are correlated. So an example would be maybe one variable is how much headcount, how many sales employees we have. And then the next variable would be how much revenue we're bringing in. You could see that there's a correlation there. The more sales reps we have, the more revenue we have. You can also make a causation about some of those things. And the reason that's important is a lot of business, you're making decisions based off of causation. So in that case, I'd say, okay, it's clear to me to make more revenue, I just need to hire more salespeople. Now, it's not 100% accurate. You obviously have the expenses of hiring them, making sure that you don't have too many salespeople, making sure the territories are aligned, but that's the concept between correlation and causation. Then we go into what I call a 3-part series on how you should really analyze your data. And the way that we do that is based off of what you're trying to analyze. So we go through univariate, bivariate, and multivariate. Univariate just means we're looking at one dimension. So we're just looking at one variable. Imagine it's a sales organization and we're looking at sales. So that one variable is the sales. Bivariate is looking at two variables and trying to compare and contrast. So if you're buying a car, what is the correlation between the sticker price as one variable and the fuel economy or the engine size or the number of doors? So when would you look at two variables and compare them? And then multivariate is looking at multiple variables. A good example there would be if you're trying to figure out in your company where you would open up another store. So let's say you're a coffee shop and you're looking around to say, okay, where is the next coffee shop that I should build to make the most revenue? What you would do is you would take a lot of demographics from your existing shops. Every item is its own variable. So you would take the revenue the store brings in. You would bring in demographics that are around the surrounding store, but not the store itself. How close it is to a highway. What's the total population in the 10 miles per radius? How many competitors are within a 10-mile radius? How close are you to schools or employees or works? And you build this multivariate model that tells you these are the factors that go into revenue. And then let's say you have 10 lots around the city that are for sale. You can also build those models for those lots, leaving out the revenue part. You know, how close it is to the highway, how close to the competitors. And using multivariate analysis, we can use statistics to predict basically where we should put the next store to get the most revenue. And the whole thing about the bundles of data analytics is you don't have to necessarily understand the statistics behind that. You could, as a hardcore data scientist, go and do all of that, but there are tools that do that for you. So you have the power to do that today, but what you need is the interpretation of that. And that's a lot of what we're teaching in the course. And I want to stress on this slide, we're not teaching you hardcore math theorems and statistical formulas. We're teaching you how to understand your data, what tools to use for these that are already available and free, and how do you interpret the results. And then the last two things that we cover are related to data analytics, because at the end of the day, what you're trying to do with data is you're trying to make a decision. Yes, do I do this? No, do I not do this? Do I invest? Do I not invest? And although decision making is an art, there's also a science to it. So there's a weekly lecture on decision making that goes and correlates to the next topic, which is how do you think analytically? And what we try to do in those two lectures is we try to get people to stop asking business questions and how to think analytically. So a good example would be, you know, if I'm in sales and marketing, my boss might come to me and say, Kevin, we did a marketing campaign last year to drum up more students for this course. I'd say that's a very valid business question, but that's not an analytical question. How can we confirm that and turn it into an analytic question? And we go through the process of basically asking questions of our questions. So my first question would be, compared to what? Is there a baseline conversion rate compared to the marketing advertisement we did last year? Was this on multiple channels? Was it done through web? Was it done through email? Was it done through phone? What are we comparing it to? And in this concept they call find the nouns, you basically ask all those questions, you highlight the nouns, and that gives you access to the data that you need to answer those questions. And then we go through the decision-making process of how do I interpret the results and how do I eventually make a decision on that. So long story short, saying that is the course that we're offering here is it's not teaching you to be a data scientist. It's teaching you how to access massive volumes of data and how to think analytically and make decisions off of it. So in terms of a prerequisite, obviously people that have more of a logic-based background or mindset will love this type of concept, but it is there for everyone to use and consume. That's the democratization of data, is everyone should be able to think analytically and make decision making. So in terms of who this course is for, I think it's for anyone that wants to make decisions that are based on that data and haven't been able to do that before. One question that we typically get around this is, how does data analytics compare to predictive analytics? So I put a couple slides here that kind of show those. If we go to this slide here. I'm sorry, Melanie, do you have a question?
Yeah, no, that was great. So, Deb, before you dive into that, Greg had a question that came through the questions section. Basically, when working and going through all those topics you went through, are there tools that the students will need to be prepared to use? Are there free tools? I know just from working with you, you do incorporate a lot of tools and technologies, and you're always looking out for, you know, we negotiated like free 30-day trials for things for the classes. But do you use specific tools that you would recommend?
I always have my favorites, obviously. So with this course, I try to give a little bit of breadth so people have options. So some things we'll do in Excel, because most people have access to Excel. I happen to work for a data analytics company called Click, so I'm able to get the students free access to Click. So one of the things will be that software we'll use, and it's a cloud-based software, so you don't have to download anything. There's a few other softwares we cover as well. When we get to Predictive Analytics, which is the follow-on course to this, there's a product called RapidMiner, which we've agreed and negotiated free access to students as well. So everything will be free. You won't have to pay for anything, and we'll try to give you a little bit of variety. But the key thing that I try to do in the course is not make it tool specific. So I won't teach you Excel. I won't teach you Click. I won't teach you any of the specific tools. I'll teach you enough that it almost becomes tool agnostic, because I don't want you to get limited to one specific tool. So yeah, there might be a little bit of a learning curve to learn tool A or tool B, but most of what we're doing is teaching you the concepts as opposed to teaching you feature functions from the tool.
Wonderful, thank you.
Sure. So yeah, so a question that always comes up is what is the difference between predictive analytics and data analytics? And you know, even through my my discussion today, I've mentioned predictive capabilities a couple of times, and this is a nice slide that kind of highlights the varying levels of analytics. So a lot of companies historically, up until about 10 years ago, only have the capabilities either because of the data. So remember the big data slide, one of the big ones is data in motion. that's relatively new. Most of the data was already happened. It was a sale, it was an event that happened in the past. So most people were able to ask questions of what happened. And we call that descriptive analytics, and that's hindsight. You know, we missed our number in Q1. We lost a sale. It tells us stuff that, you know, one item at a time you might already know, but when you're looking at lots amount of data, it does give you some hindsight into what happened. But the next question that most companies will ask is, why did it happen? And that's where you get into diagnostic analytics, which is some of the stuff we'll learn in this course. Well, it happened because of ABC. Was there a correlation or a causation? Did it happen because our sample size wasn't random? Did it happen because a competitor put a product to market that took more of our market share away? So using the data analytic techniques we'll talk about, we will not only answer what happens, but we'll answer why it happens. And that's kind of where this course ends. And then there is a follow-up course around predictive analytics, and that picks up basically where we answer what will happen. So I want to predict my sales for the next 12 months. I want to predict which customers are more likely to buy this so I can advertise to them. And then the final thing gets to more of a business optimization. How can we make it happen? So you actually flip the script and you actually set up your business to get the results that you want to get. And that's kind of the holy grail for a business. So we start with the fundamentals and then we move into the predictive foresight concepts. And how we do that, if we break down predictive analytics, there's basically three components, and I'm simplifying a little bit, but there are really three things that we look at that tell us what will happen. The first technique or group of techniques is called forecasting, and you're probably pretty familiar with that. It's used to forecast outcomes that are of a continuous nature. So how much will the specific customer spend in the next month? What is the forecasted movement of our portfolio on a weekly basis for the next 12 weeks? It'll use your historical data and some statistical modeling to forecast what you're going to do in the future. Another common technique we'll look at is segmentation. Segmentation is used across many industries. So basically it's used to bucket, or the technical term is cluster, people or groups or variables into particular segments that have similar behavior. So a common example here would be if you're trying to send out an ad and you only have a certain set of money to spend and you have to target specific customers, you would say, okay, I want to find all customers that have the highest likely to buy or return this ad favorably. You're going to cluster your entire population around variables that tell you who's most likely to use the coupon. Another example that's big is in banks and insurance. So a bank will use segmentation to say these customers are high risk because they have variables that are similar to customers who in the past defaulted on their loan that have similar trends or variables. Or insurance companies will say this group of people left our insurance to go somewhere else last year. We want to prevent future people from leaving. So we want to model and segment out of our current customers, which are the top 10% most likely to leave. And then what do? Maybe we send them a, hey, I'm just thinking of you, or maybe we send them a welcome email or something that just shows them we care to try to prevent them from leaving. So segmentation plays a huge part in the business. And then the example I gave earlier about the coffee shop, that is logistic regression. So it's used to predict a binary outcome. Will a customer respond or not to my marketing offer? What is the chance the customer will enroll in the next 12 months? What is the chance that this store, this coffee shop, will be profitable based off of the location? So we talked about the data analytics, and then these last two slides are around the follow-up course, predictive analytics, which again, you don't have to be a data scientist about, because everything that we've talked about earlier shows there's tools that allow us to access the data. There are tools that already built the statistical models for us. We just have to be able to speak analytically, interpret the results, and act on them. And that's really what these two courses is: understand data, understand how to think analytically, understand how to make decisions.
All right, so keep your questions coming. We want to be able to use the next couple minutes to get some more questions answered. Greg, thank you for kicking us off with the questions. So I will just continue to interact with Kevin and talk a little bit about the format of the class. I want to hear from you, so I'll pause at any time to make sure your questions get answered. Thanks, Kevin, so much. So we have the upcoming course, Fundamentals of Data Analytics. It begins May 1st. It's 100% online, instructor-led by Kevin, week after week, 6 weeks long. So week after week, he's going to pace you through the class, provide you, every week assignments, discussion board topics, ways to interact with the tools that he was discussing, ways to interact with the curriculum, some readings. All of the materials are included. He's going to pace you along, and then I'll let him explain a little bit more what happens in each week.
Yeah, happy to. So I don't know how many people are familiar with online courses or not. We try to make them as enjoyable as possible. Obviously, there's a self-paced component. So every week there's video lectures. I try to make lectures usually about 10 to 15 minutes or less. And if there's more to say, there's just multiple ones, and that way you can kind of time them as you want through the week. There's reading assignments. Sometimes in this course, it's notes from me. Sometimes it's articles online that talk about things like the analytics gap, just to give you that kind of current events feel. Or sometimes it's a case study of how a business used analytics to further themselves. Then when you get to the actual assignment, sometimes there's an assignment that's hands-on. Sometimes the assignment is just a discussion question. It really depends on the scope. The assignments are not intensive assignments. They would be using a tool like Excel to answer a business question. An example discussion question would be, if we go through and learn about A/B testing, I would say, what would be a real world application of A/B testing? And then you get the collaborative effect of everyone in the class sharing their stories of how it works. And that really helps foster the learning, because you're not just learning from me, you're learning from other students. And another example of a discussion question would be, what's the downside of democratization of data? That question in of itself is not teaching you analytics, but because you're all using this to further yourself in business, it's good to hear sometimes not just the good side, but also the bad side. So we use these forums a lot to allow students to express what they've used in the courses. There's no quizzes, there's no final exam. It's really just assignments that can be done hands-on on a weekly basis, and then it's collaboration through the discussion forum. And again, the videos you can watch at any point during the week. Usually they're anywhere from 10 to 15 minutes, and most of the weeks have at least a couple of them. I would estimate spending about 3 to 5 hours a week, depending on how much you want to get into the reading. And there's a ton of optional reading where you could spend much longer, but we try to limit each week to that time commitment, so that it's doable and achievable, because the topics build on each other every week.
Yeah, so yeah, like you said, there's, we average 3 to 8, which I know is kind of, that's kind of our average time spent in the classes for most of our classes, but especially this one. So we're kind of asking our instructors to plan, because many of our audience are working professionals and are juggling multiple things, as everyone is. Also, this course, at the completion of this course, you will receive a digital badge, which can be placed on your LinkedIn profile. So this isn't tied to, at this time yet, we're still thinking about planning for future certificate programs with a bundle of courses. But right now, this is the standalone course for a certificate in Fundamentals of Data Analytics. Let's see, so we have a couple questions. Zach has just popped in one. What is the base level of math literacy required for someone to be successful in your course, Kevin?
That's a great question. I really want to say basically high school math. I don't think you need anything more than that. And when I say high school math, I don't mean algebra or calculus, geometry. A lot of what we're teaching assumes that you know numbers and obviously addition and subtraction, but we don't go into hardcore geometry, calculus, algebra. We teach you some of the statistics angles, but I don't think you need more than a basic literacy of math. What will help you if you have that logic background, students that have a logic background tend to pick this up faster than students that come from an arts degree. But we've had many students, thrive in that environment. I only mention that because when I teach something like, for example, an average, that might seem very straightforward and simple to both sides. But when I go into something like statistical inference, I find that people that just understand logic, so they've had some math courses, whatever, similar approaches, pick it up a little bit easier. But we've had many that from both sides that have taken these courses and thrived in them.
Great. Yeah, so Diane Dukes also has another question, and that is regarding how does this course content complement the Greenbelt content? And so what I think she's alluding to there is PACE also offers a Lean Six Sigma Greenbelt certificate program, which is 5 courses. And, just off the top of my head, it's lean process improvement. But off the top of my head, we're currently offering this program at a semiconductor company in Bend, Oregon. And they're looking at Lean Six Sigma to help improve product and process excellence within their organization and improve goals such as in customer service excellence and also enhancing shareholder value creation, which is an interesting way to implement Lean Six Sigma. And so if I'm thinking about data analytics and understanding the data to be able to articulate the shareholder value or the customer service implications or improvements that can be made to the process, I think that this content is very relatable. Kevin, do you want to talk a little bit about that? I know that you know a lot about Lean Six Sigma as well.
Yeah, as well. So I mean, when you're getting into process improvement at a company, a lot of this is a science, not an art. So there's a lot of things you do around assessments and evaluations. And when you make recommendations to whoever the customer is, it always has to be evidence-based, fact-based discussions. And a lot of times, if it's a survey, you're going to be doing some basic data analytics on the survey. You're going to decide how is the data distributed. Am I looking at continuous or categorical variables? Am I showing an average or a median? Am I showing a correlation? So in my process improvement, I can say, we have new hires, and I can say through my analysis, there is a correlation that new hires that are in this region are not performing as well as new hires in another region. And it's not a result of the leader, it's a result of a process in that region. All of those things you can't say subjectively in Lean Six Sigma. It has to be evidence-based and fact. So I think they tie really well because this is teaching you about data. So when you go on, you try to do your process improvement, one of the aspects of building an intervention is doing the assessment and analyzing the assessment and building a story that's very objective and fact-based. And I think this course will actually go a really long way to complement that.
Great question, Diane. Great, keep the questions coming. So again, before we move on here, so May 1st to June 11th, so it runs right up until the end of, or start of summer, 100% online, very interactive. Kevin is very interactive, is talking to students daily in his online classes. We ask the instructors try to respond within 24 to 48 hours so that, they're kind of pacing you along, but Kevin's probably instantaneous. I've noticed, and I've worked with you for years. So thank you so much for just your dedication to our learning adults. So we've kind of budgeted about 24 hours for this learning experience over 7 weeks. What else? Is there anything else about the course, Kevin, and kind of how it's set up? And again, questions about that, feel free to chat them to us.
Yeah, I guess the only thing I'd say is, I don't know how many people have done online courses before, but if you're nervous about it or you have specific questions you don't want to ask in front of people here, feel free to send the email in to us, and we'll be happy to answer it even after the webinar, because we want to make sure people are comfortable in an online environment.
Mm-hmm. Absolutely. So yeah, there's a lot of communication. I feel like you have access to him pretty much, that entire 7 weeks to then work on a lot of your existing projects as well. You can weave in your work into our courses and to have that help to apply what you're doing next day on the job. Good. So let's see. My mouse has been a little crazy. I apologize. So who should be in this program? So, you know, here we kind of think anybody that's interested in data analytics, interested in, you know, even how it relates to process improvement, knowing more about your data and how to interact with your data. You're going to learn, you know, the purpose of data analytics in the real world and examine the real world data, apply these foundational concepts. You're going to learn how to interpret that data. So Kevin, do you want to talk a little bit about, you know, the target audience of this too, who might be interested?
Yeah, I think it goes down to, you know, from a prerequisite, you don't have to have any background or any job in math or science or statistics. It's anyone that has to make decisions in business world that wants to make decisions based off of objective, fact-based evidence, which is the data. So you can go anywhere, use a ton of these, you know, this is in previous locations, I've taught a ton of grade school teachers because they need to make fact-based empirical evidence on their students. It ranges from that to, you know, CEOs that need to make decisions in their company. So this is one of those courses where I expect every student to be completely different than each other because they all have to learn about data, but you're probably all coming from different industries and all different levels within the organization.
Absolutely. Good. So our PACE programs, and this class included, so really what we're trying to do is provide you theory-based understanding with practical application. So you're really applying what you're doing to your day job. We have a lot of courses that people just take drop-in for one course or are enrolled in the program. So we're open enrollment courses. And you know what you're learning should help you bring immediate return to your investment, to your work, and help you to diversify your resume skills, add this digital badge to your LinkedIn profile. And I really love that Kevin layers in that state-of-the-art technology. So, and it's sprinkled in all of our courses. But thank you again, Kevin, for negotiating hard to get all of the access to these state-of-the-art tools in this class. I'm really excited about all the tools that the students will be able to manipulate and use. So thank you for that. All right, so how to get started. So again, registration is open. Currently, courses are starting May 1st. And if this is your first online class, we open registration usually that weekend before, so you can start to navigate around. You introduce yourself. You start to get familiar with Canvas as our learning management system. It's organized really nicely, and you can always tap us and ask us questions about how to navigate, and we're happy to sit down with you and walk you through the Canvas learning management system if this is your first time learning online. We also want to offer you, and thank you so much for attending this webinar, and offer you 20% off, a discount coupon. So after today's presentation, we will send you these slides as well with the coupon code. And Kevin's contact information is here, and my information, and Paula is the project manager for this program. And so we want to thank you so much. We'll stay on just a little bit longer to make sure we get some more questions answered. Kevin, did you have any final thoughts before we conclude?
Nope, I'm good. I appreciate everyone taking the time who's listening to this live and to the recordings. And like you said, if anyone has any questions, please don't be shy to reach out.
Great. Well, thank you so much. We'll send you the information, the slides, and also the syllabus is online if people want to take a little bit closer look to what's happening each week in the course. And we thank you so much for your participation and being here with us today. All right. Well, go Beavs. Have a great rest of your day, everyone.